All right, let's take a look at this problem. And I apologize, I accidentally printed off the wrong words in the wrong order. So I'm just going to make a little variation on this. So it says that a 5 kilogram concrete block is lowered with a downward acceleration of 2.8 meters per second squared by means of a rope. We want to know the force of the rope on the block. So how much force does this rope provide on the block? Well, this is a pretty easy question to go through. It just requires us to be careful. So we have a block. It's being lowered. I'm going to make this a nice little crane that lowers this. So this thing is being lowered with some acceleration. All right, so now what I want to do is I want to draw my free body diagram. So my free body diagram, I'm going to draw just the forces on this block of mass M. If I go around and start thinking about this, well, this block is being pulled towards the Earth by a weight force. This object has some weight. It wants, if we cut the cable, it's going to fall towards the Earth because the Earth is pulling it towards it. It's not falling towards the Earth because there's a tension force. The rope is pulling upward on it. So if we were to cut the rope, this thing would fall really fast. It's not falling really fast. It's falling relatively slow. Not horribly slow, but moderately slow. And the reason why it's falling slow is because there's a tension force on it. So I look and I go, are there any other forces? It's not touching anything. It's not interacting. Nothing's pushing on it or pulling on it. No air resistance, no friction, no other forces. I know I drew an acceleration in there, but that's an acceleration. That's not a force. So I think I got all my forces. So let's go ahead and see what this does. So when we draw a free body diagram, in the back of our head, we're thinking Newton's second law. Sum of the forces is going to give us an acceleration. So if I add up all these forces, I'm going to get an acceleration. I have an acceleration, so I want to know what is the forces that gave us that acceleration. So I'm going to go put a coordinate system in here, positive x, positive y. All right, I'm going to go in the y direction first. Nothing in the x direction, so I'm just going to kind of forget that. Just going to go in the y direction. So I'm going to go around and I'm going to look at each one of my forces and ask, is there a y component to it? So the tension force. It's got an upward value to it, a positive value because it pulls upward. I get to my weight force. It is a downward weight force. And last but not least, I've added up all my forces, so now I jump over to the inertia side. I have my mass times a minus acceleration. My acceleration is 2.8 meters per second, and it's in the downward direction. So I have T minus, well, my weight force is mg, is equal to m times minus a. Or T is equal to mg minus ma. The weight force minus our acceleration term. So when I plug in the numbers for this, I'm going to get 5 kilograms times the quantity 9.8 meters per second squared, because it's a positive value of 9.8 meters per second squared. I included the negative sign to be the downward part of it. And I need to subtract off my acceleration, my downward acceleration of 2.8 meters per second squared. And if I plug in stuff, this is 5 kilograms times 7 meters per second squared, which gives me 35 newtons. Kilogram meter per second squared. Just making sure that my units work out, and kilogram meter per second squared is in newtons. So 35 newtons, and we can see from our picture it points in the upward direction. So our tension in our string pulls up at 35 newtons. It might be interesting to note that 5 kilograms times the 9.8 meters per second squared is approximately equal to just a hair under 50. That's actually we can actually get the right number, 49 newtons. So 35 newtons is our tension. That's how much it pulls up. But gravity is pulling down on it with 49 newtons. So gravity is going to win. It's going to provide a downward acceleration. So even though we're pulling up on it, gravity is still winning. It's still being lowered at a certain rate.